Hi guys, it's Jane here, and in today's video we are going to discuss about the fluids and electrolytes overview. I would show you all of the formulas needed to calculate all the values, and
if you're interested to try out an example, I have linked the video down below. Now that said, let's go!
If you guys could recall, our body is comprised of 60% water, and the water is divided into two compartments, which is the extracellular fluid and the intracellular fluid, which they also have a different ratio. So it's 20% for the ECF and 40% for the ICF. And of course, they also have their dominant electrolytes, which is the sodium at the ECF and the potassium at the ICF. All right, so as we go through this video, please keep this basic in mind so that it's easier to refer.
All right, so now let's talk about the concepts. So to calculate the total volume needed for one person, you have to know the maintenance fluid of that person, which is the volume of fluid that person needs in one day to function normally. And then the deficit volume, which is how much volume that person has lost throughout the course of the disease, and then the ongoing loss. The next thing you have to pay attention to is the sodium, because the sodium would indicate the choice of fluid we are going to use, especially in pediatrics where there is a lot of fluids like 3%, 0.9, dN over 2 up till dN over 5. And the last electrolyte we have to consider also is potassium, but I am not going to be discussing about potassium in this video. So now let's look at the steps that I would take when I am going to assess one patient. So first of all, I would think about the volume. So the volume that I'm going to have to find out is the volume maintenance of that person, which the units would be in milliliters per 24 hours. And I would also have to find your volume deficit, which the unit is only in milliliters. And the next value I have to consider is the sodium, okay, which is totally like mirror image of the volume. I need the sodium maintenance of that person and their sodium deficit. And the last thing is excess sodium loss. So this would only be calculated if that person has a serum sodium that is lesser than 135. So there are two ways a person can go through finding this, okay? The first one is the Holiday-Segar method, which this formula is going to give you the fluid needed daily, and there's the estimate, which would give you the hourly rate. So how do we do this? It's very simple. Let's start with the Holiday-Segar method. So the Holiday-Segar method gives you a ratio of 100 to 50 to 20. And mind you, this is milliliters per kg per day. So what you're going to do is that the first 10 kilograms, you are going to give 100 milliliters of volume each. Okay? And the second 10 kilogram, you will give 50 milliliters per kilogram each. Okay, this is the second 10 kilogram. And whatever kilogram that is left, I'm just going to use a star, you would give 20 milliliters per kilogram each. Okay, so a star kg. All right, this two formula mirrors each other. So for the estimate, it's exactly the same. The first 10 kilograms, you would give 4 milliliters per kg. And the second 10 kilograms, you'll give 2 milliliters per kg. And whatever that is left, you would give 1 milliliter per kg each. All right, so let's do an example. Let's say our patient was 22 kilograms. So if we're going to break this down, it's going to be 10 kilograms plus 10 kilograms plus 2 kilograms, right? On both sides. Okay, so let's start with the Holiday-Segar method. So 10 kilograms multiplied by 100 milliliters, right? Because it's per kilogram. So that will give you 1,000 milliliters, plus the second 10 kilogram, which you have to multiply with 50 milliliters, and that will give you 500. And the last 2 kilograms, you're going to have to multiply it with 20 milliliters, and that would give you 40 mLs. So the total volume needed per day is 1,540 milliliters in this patient. And that's how much maintenance fluid that person needs. Now, if I want to find the hourly rate of how much I have to give this person, I'm going to have to take the total and divide it by 24, because in one day we have 24 hours, right? And the amount that I would get is 64.1, right? So let's just round it to 64 mLs per hour. And I totally did not use a calculator for that. Teehee. All right, so for the estimate is totally the exact same thing, but now we're just going to have the hourly rate. So 22 kilograms, break it down, you get 10 kgs, 10 kgs, and 2 kgs, right? Right. So 10 kgs multiplies by 4 ml, which would give you 40. 10 kgs multiplied by 2, which gives you 20. And 2 multiplied by 1 would give you 2. Okay, now you add everything all up, you would end up having 62 mLs per hour. Okay, so see that? That's not much of a big difference, but it was way shorter than the holiday cigar method. Now let's talk about the volume deficit. So to understand a volume deficit, first you're going to have to know the hydration status of a person. And that's the most popular chart all medical students would know, is the dehydration chart. All right, but there's a difference for a pediatrics patient. So if the kid is more than 1 year old, the percent you have to use is 3% for mild dehydration, 6% for moderate dehydration, and 9% for severe dehydration. However, if the patient is lesser than 1 year old, you're going to have to change that number. It's going to be 5, 10, and 15. And that's because kids, the younger they are, the more water they have, okay? In red, I have written the formula for volume deficit. And volume deficit would be percent dehydrate multiplied by 10 and multiplied by the body weight in kilograms. Okay, so let's do an example. Okay, so let's use the previous example. So that kid was 22 kilograms, and let's say he was around 3 years old, okay? And I have assessed him, and his dehydration status is moderate. So moderate would fall at 6%, right? So I'm going to have to take 6, multiply by 10, multiply by his body weight in kilograms, which is 22. And my answer would be 1,320 mLs. Okay, so that's pretty simple. Yay, now we could find a volume deficit. So the next value we are going to talk about is the sodium maintenance. So the principle is that person needs 2 to 3 MEQs of sodium per 100 kcal per day. To not be confused, 100 kcal, we are just going to assume it to be the volume maintenance, because the volume maintenance is how much water a person needs per day. Okay, so don't be surprised by that. And the formula here is in red as usual. Sodium maintenance is 2 or 3. You could choose your pick. I usually take 3. Multiply by the volume maintenance divided by 100. And actually this is not any random numbers put together, okay? It's a what's that called? A rule of 3 arithmetic, if you guys could still recall. It's really simple actually. So let's say that 100 kcal is 2 to 3 MEQs of sodium, right? So the volume maintenance kcal that we have, how much sodium do we need? So all we have to do is the crissy-crossy thing, if you guys could remember from high school. All right, crissy-crossy. So volume maintenance, you would multiply with it with 2 or 3 MEQs of sodium and then divide by 100 kcal. So that's how everything comes together. The next value is our sodium deficit. Now, the timing for sodium deficit is really important. If the dehydration was an acute dehydration, which is less than 3 days, the ECF would have lost more compared to when it is a chronic dehydration, which is more than 3 days. So as you can see the ratio here, in acute, the ECF would have lost 80% and the ICF would have lost 20%. Now if it's chronic, the ECF would have lost 60% and the ICF would have lost 40%. So you could see the shift of ratio between the acute and the chronic time. So the formula again is given in red here. Sodium deficit is volume deficit in liters, okay? So all of this we had calculated from the beginning was milliliters, but this time we're going to use it in liters, okay? Then you multiply by the percentage of ECF, and then you multiply it with 145. So where did this formula come from? So we assume that in 1 liters of ECF, there is 145 sodium, okay? So the same concept, crisscrossy concept, volume deficit ECF would equal to how much sodium? So crisscross, right? And this is what you'd get. Volume deficit multiplied by 145 divided by 1. So we finally reached the last value that we have to know how to calculate, okay? And that's the excess sodium loss. As usual, my formula is in red. So the sodium excess loss is sodium desired minus serum sodium, the current serum sodium, all right? Then you multiply it with 0.6 times the body weight in kilograms. So the sodium we desire is 135, okay? So that's a number you have to remember. And 0.6 is actually the total body water, which was 60%. And the body weight, as usual, we're going to use the kilograms. But there is a precaution here, okay? So no matter how low your sodium is, you are only allowed to correct 10 to 12 MEQs per day, okay? You don't want to correct more than that. And that's because we worry about the demyelination syndrome if we correct the sodium rapidly. Now that we know how to find individual values, let's put them together. So there are many ways you could correct it, and one of the most practical ones is by replacing everything over 24 hours. That's the most practical way. However, if you want to rapidly correct the dehydration status, you would use the 50-50-8-16. And I'm pretty sure you've heard about this in the burn section unit where you have to calculate all the stuff. And yes, that's how you actually give the fluid to a dehydrated patient too. Let's look at volume first. And the sodium basically mimics the volume, so I'm not gonna show the sodium here. So first let's talk about the maintenance volume because it's easy to understand. So maintenance volume, the total of the maintenance volume, you would correct it over 24 hours. The first 8 hours, you're gonna give 1/3 of the total maintenance. The second 8 hours, you would give 1/3 of the total maintenance. And the third 8 hours, you're gonna give 1/3 of the total maintenance. 8 times 3 is 24. Now let's look at the deficit. Now the deficit is the one where the 50-50-8-16 comes to play. So 8-16 is first 8 hours and second 16 hours. And 50-50 is where you divide the deficit into two equal halves. Okay, so the first half would be given within 8 hours, and the second half would be given within the next 16 hours. Let's look at this in a slightly different view. Okay, so what do we need to have in the first 8 hours? Okay, the total volume would be volume maintenance divided by 3 plus volume deficit divided by 2. And the rate of this 8 hours would be the total volume divided by 8 hours. And the sodium, as I have mentioned earlier, is the exact same thing. So sodium total, 8 hours, is sodium maintenance divided by 3 plus the sodium deficit and also the sodium excess loss divided by 2. All right, so that's quite simple. Now, let's look at the 16-hour mark. So in the 16-hour mark, your total volume would be slightly different. You're going to have to take 2 multiply by the volume maintenance, okay? And as we talked about earlier here, the maintenance volume is given over 24 hours. So during the first 8 hours, we have used up 1/3 of our volume. So now we are going to need to use these two, okay? So 8 plus 8 is 16. And then you have 2 multiplied by the volume maintenance over 3. So that's the origin of it. And the volume deficit is the same. You divide it by 2 and you're good to go. To find the rate, you'll take volume total divided by 16 hours. Sodium total for the 16 hours is exactly the same. 2 multiply the sodium maintenance divided by 3 plus sodium deficit and the sodium excess loss divided by 2. So at this point, I know you guys are excited and you guys probably would want to start calculating and stuff. But before that, let's talk about the fluids first. So we have to know, like in one intravenous fluid packet, how much sodium do we have? These are the common ones that you would find, but I wouldn't be talking about them in this video. So the 3% NaCl has 513 MEQs of sodium per liter. And the normal saline, which is 0.9 NaCl, has 154 MEQs of sodium per liter. Now, let me show you guys how to find the rest without remembering all of these. So dN over 2 basically means the sodium, the total sodium of the normal saline divided by 2. So this is how it goes. dN over 2 means 154 MEQs divided by 2. And once you punch in these numbers in the calculator, you would get 77. Okay, so that's that. Now, how are we going to choose the fluid? So you're going to have to know how much fluid that patient needs and how much sodium that patient needs, okay? And you're going to have to go and compare it to the 1 liter bag the hospital give and how much sodium you need. So that's the same thing, crisscrossy. And with the result that you've calculated from this chunk, you are going to have to choose the fluid with the most similar sodium concentration.
Hey guys, sorry for cutting in so abruptly like this, because if I don't, the video would be too long. And first of all, congratulations to all of you who have reached the end of this video. It was a long one, I know, and I hope you guys were able to learn something from it. This is the first time I've ever done a teaching video, so if you have any questions, please comment down below. And in the description box, I have posted a link that would lead you to a video for a sample calculations based off this topic. If you're interested to go try it out, please do so, and I will see you in my next video. Bye!